In this video, we're going to take a look at proving triangles similar. Now, unlike before, we proved triangles congruent. This is going to be a little bit different. We've dealt with congruent triangles. Remember we talked about like SSS and SAS and ASA, AAS, and HL. Proving triangles similar is different in two ways. The first way is that there's only three theorems we need to know. Angle, angle, side, angle, side, 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 side. So that's the first way. The second way that it's different is that when we talk about proving things similar, when we say side, angle, side, we don't mean two sides congruent to each other. We mean sides that are proportional. Remember, proportions look something like this. A proportion is when we get two ratios and we set them equal to each other. So for example, if I have 1/2 and 2/4, those two proportions are equal to each other. All right, so we're looking for congruent angles and proportional sides. Now this is going to be a whole lot like congruent triangles. So let's roll back our what we remember. So remember with congruent triangles, we had vertical angles, reflexive sides. We aren't going to deal with reflexive sides as much, might deal with a reflexive angle, but we are going to deal with some vertical angles. So let's start with some angle ones. Okay, so angle means I have two angles equal to two other angles in a triangle. So notice here, remember, when we see these little markings, okay, the 1 mark and the 2 mark, it means it's the same size as the 1 mark and the 2 mark on this triangle. It doesn't mean that this 2 markings is bigger than the 1 marking. It just means that they're like names, okay? Or it's like saying that they're the same. So angle A and angle D are the same. Angle B and angle E are the same. So whenever we see those markings, those are things we can count. So let's take a look at this. Are these triangles similar? Well, I notice I've got a 30-degree and a 30-degree, so that checks out. I've got a 90-degree and I've got a 90-degree, so 2 thumbs up. I don't even have to look at the sides. I've got an angle and an angle. These triangles are similar. And remember, our key shape for similar is this one squiggle, okay, instead of doing congruent where it has an equals underneath. All right, so let's look at another one. Okay, so I see I've got an angle right here, right? I've got an angle on this side. Now remember, I've got to count all of my angles and sides on one triangle. I can't jump from this angle to this one over here and go angle, angle. So that's all my markings. Do I have any vertical angles I can count? I sure do. I've got one right there. So I've got an angle. I've got another angle. Okay, so these are similar. Yes. How so? Angle, angle. All right, so angle, angle is the easiest one. Hopefully you can knock these out of the park. Okay, now when we get to side, angle, side, it's a little bit trickier. So what we need to do is we need to set the sides up proportional. Okay, so what I'm going to do is I'm going to set up one side. So notice I have an angle here. Okay, and I've got side, angle, side on both of these. So far it looks good, but look at what I'm going to have to do. I can't just check to see if the sides are equal because they're not going to be equal, but I can check to see if they're proportional. So I'm going to match them up. So AB matches DE. So this is just like we did with solving. I'm going to set them up, and then instead of setting one up with an X, what I'm going to do is I'm going to set this one up over here, 14/21. So now what am I going to do? Well, I'm going to plug this in my calculator. I'm going to do 8/12, and I get 0.6 repeating. And then I'm going to do 14/21, and I get 0.6 repeating as well. So those sides check out. If that number isn't the same when I set it up on my calculator or on Desmos, I would do it 2 separate times, 8/12, 14/21. If they're not the same, they cannot count. You cannot count the sides. So let's look at a couple options here. So let's check this one. Okay, notice there's no letters, there's no similarity statement. I do know I have that vertical angle, right? So I know I've got an angle. Now let's check our sides. Now here's the question. Do I set it up like this? 4/6 is equal to 6/9. Or do I set it up like this? 4/9 is equal to 6/6. Well, let me kind of show you a trick here, okay? Better than looking at the triangles, because sometimes they're drawn kind of funny, kind of like this one. What I'm going to do is I'm going to pick the smallest on one triangle. Let's look at the second triangle. I'm going to match it with the smallest on another triangle. So that's my 4/6. Then I'm going to take my largest, and I'm going to set up my other fraction, okay? So we want to set it up that way. We don't want to set up the smallest with the largest. We want to go smallest with smallest, largest with largest. All right, so let's try this out in our calculator. 4 over 6, that's also 0.6. 6 over 9. All right, these check out. So far, so good. These are both equal. Now let's look at one more. Let's see if this works for us. Okay, so again, I'm going to set smallest over smallest, 4 over 2, and then 6 over 3. Okay, so 4 over 2, 6 over 3. That checks out. Those are both equal to 2. So I've got two sides. I've got an angle, but wait a second. I've got side angle side on this one, but look what I've got over here. This angle, it's not in between my sides. I cannot count this angle because I only have, this actually turns out to angle side side. And remember, if it spells a bad word, don't use it. If you get ASS, that's no good. Not allowed to use that one. All right, so we get side angle side side. That's no good. Okay, let's move forward. All right, last one is side, side, side. Now, just like before, we're going to set them up. Smallest over smallest, medium over medium, largest over largest, and set them up equal to each other and see if they come out the same. So let's go ahead and try this one. So my smallest here is 5. I'm going to set up with my smallest here at 3. 5 over 3. Is it equal to 6 over 4? And is that equal to 7 over 5? Okay, so let's go ahead and try that in our calculator. So 5 over 3, that's 1.6 repeating. 6 over 4, I get 1.5. And let's just check that last one, 7 over 5, 1.4. All right, are these the same number? No, these are not similar. Even though I have side, 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 I need these fractions to be equal, and they are not. So these are not similar. Okay, anytime you're setting up your sides, you need to see if the fractions end up equaling each other. If they are, thumbs up. If not, it's no good. All right, let's look at one more here. Okay, same thing again. We're going to go smallest over smallest. So 24 on my first triangle, 56 on my second triangle. Then I get 27 over 63 and 33 over 77. Let's plug these in our calculator. 24 over 56. I get 0.42857. I'll just round it to 6. Let's check the next one. 27 over 63. I get 0.4286. All right, this is looking pretty good. All right, and they need to be exactly the same the whole way down. 4286. All right, this checks out. See how each of these are equal to each other. So yes, these are similar, and they are similar by side, side, side. All right, so big idea here. Angle, angle, side, angle, side, 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 side. Those are the ones that work. All right, you have to set up your sides in a calculator to check to see if they are proportional or not. This wraps up our first lesson on proving triangles similar.